Hello students, today we will be studying about bromine and iodine, the methods of preparation and their physical and chemical properties. So now let us start today with bromine. As you can see, bromine occurs mostly in the form of magnesium bromine. It could also occur in the form of the ore of silver bromide, right? That is either as AgBr or as MgBr2. Okay, and MgBr2 is primarily found in seawater. Now regarding the preparation of bromine, first method, that is the laboratory method of preparation of bromine, as you can see, sodium bromide reacts with concentrated sulfuric acid in presence of a strong oxidizing agent like manganese dioxide, giving rise to sodium bisulfate, manganese sulfate, bromine and water. Now over here, this Br minus, it gets oxidized to Br2, and here MnO2 acts as the oxidizing agent for carrying out the process of oxidation. Next is the commercial method of preparation, in which we see that bromides are oxidized by chlorine gas. That is, as you have seen in the previous reactions, the higher halogens are capable of oxidizing the lower halogens. So over here, chlorine being the higher halogen in the group, that is, its atomic number is quite less than that of bromine. So it is capable of oxidizing Br minus to Br2 molecule. Now Br2 being quite volatile in nature, it can be removed once it formed. It can be removed by passing a stream of air and then collect it. Right? Now over here we see that this Br2, which is removed by a stream of air, may contain some impurities or may contain water. Now these are removed by passing this Br2 formed through sodium carbonate. What happens if sodium carbonate is added to Br2? We see that we get sodium bromide, sodium bromate and carbon dioxide. Now this sodium bromate and sodium bromide, both these contain the bromine. So these two are taken and they are made to pass through concentrated sulfuric acid or concentrated HCl, as a result of which the bromate from the bromide Br from both these compounds gets displaced in the form of bromine. This type of reaction is an example of what we call the comproportionation reaction. That is, a higher oxidation number and a lower oxidation number give rise to an intermediate oxidation number in the product. Over here, as you can see, Br minus is having -1 oxidation number, and over here BrO3 minus has got Br in +5 oxidation state, but Br2 being in 0 oxidation state. So -1 and +5 giving 0 oxidation state, hence a comproportionation type of reaction. Next we move into the physical properties of bromine. First physical property is it is a reddish brown colored liquid at room temperature. It's poisonous, it's water soluble. Now it can't be said that it's highly water soluble, but it is definitely water soluble to a good extent. Chemical properties, we see the direct combination of bromine with hydrogen in presence of platinum, which acts as a catalyst at a temperature of 200 degrees Celsius, giving rise to HBr. Next is combination of bromine with water, giving rise to hypobromous acid along with hydrobromic acid. Now this hydrobromous acid, as you have seen for HOCl, HOBr also undergoes decomposition, giving you HBr and oxygen. It is because of this oxygen, Br2 acts as a mild oxidizing agent and it has got slight bleaching action. Now next we move into the third property of bromine, that is, it reacts with the halide of the lower halogen, displacing it to give rise to the molecular lower halogen, and itself gets reduced to Br minus. Uses, quite simple uses. First one is it is acts as a oxidizing and bleaching agent. Second is in the preparation of organic compounds and bromides, and third being in the preparation of reagents and medicines. You will find that several organic reagents as well as inorganic reagents, they contain bromine. Now next we move into the iodine's occurrence. Iodine occurs primarily in seawater as sodium iodide, as well as it occurs in the form of mineral deposits, and it's called caliche. Now this caliche is nothing but it's the mineral deposit of gravel, sand and nitrates. That is, often we see that with sodium nitrate you can get sodium iodate. This is called caliche. Okay. Now preparation. First method is the lab method, in which we see that a mixture of iodide along with concentrated sulfuric acid and manganese dioxide, if heated, it liberates iodine along with manganese sulfate, potassium bisulfate and water. The reactants are similar to that of what we have seen in case of bromide. Next is the commercial method of preparation, in which we see that sodium iodide reacts with manganese dioxide in presence of concentrated sulfuric acid, giving this particular reaction. But over here what we see, the difference is here it is NaI, but whereas in laboratory it is Ki. So industrial method is directly from seaweeds or from NaI, sodium iodide. Now here the iodine formed is condensed and then collected in earthen jars. To condense iodine is very easy, because iodine primarily exists in solid state and it's highly sublimable. So it's quite easy to condense iodine. Next is the from caliche, that is sodium iodate. When it reacts with sodium bisulfate, it gives rise to sodium sulfate along with sodium bisulfate. See over here it's bisulfite and here it's bisulfate. So here that's difference you need to be very careful about, along with water and iodine. Now here you have to keep in mind this sodium bisulfite which we add with sodium iodate has to be in calculated amount. Otherwise what happens is this sodium bisulfate reacts with iodine in presence of water, giving rise to sodium bisulfate and Hi. That is, the iodine produced over here, it gets destroyed in presence of water to give rise to hydroiodic acid, which is a reducing agent. Therefore, calculated amount of sodium bisulfite needs to be taken. Next is purification. Now this iodine liberated here may contain impurities like chlorine, bromine and water, which can be removed by distillation over potassium iodide. This method is nothing but simple illustration of the oxidizing property of the higher halogen compared to that of iodine. Here we see that if chlorine is, the impurity of chlorine can be separated by taking Ki and then making it react with the chlorine, as a result of which you get the iodine. Ki reacting with Br2, you get KBr along with liberation of iodine. And this impurity of water is removed by distillation over concentrated sulfuric acid, because sulfuric acid is a good dehydrating agent, and then you sublime and condense the iodine vapor that is remaining in the medium. Among the properties of iodine, first one is it is soluble in Ki, that is iodine is slightly soluble in water, but it's highly soluble in potassium iodide. Reason is it forms a triiodide ion which is yellow in color. The structure of this triiodide ion is linear with the central iodine forming two single bonds. Now this is the reaction that takes place between iodine and potassium iodide, that is Ki plus I2 gives Ki3. Next is, it is the least soluble in water among all the other halogens. It is soluble in organic solvents like chloroform, CCl4, benzene, ethers and any other organic solvents, and it gives a violet color in organic medium. It does not displace Cl minus or Br minus, but displaces Cl plus 5 and Br plus 5 from their salt. As you can see, chlorate gets reduced to chlorine, bromate gets reduced to bromine in presence of iodine. Chlorate and bromate salts shows chlorine and bromine in plus 5 oxidation state. Right? Next we move into the last, that is the uses of iodine. Iodine first uses, it is used in medicine as tincture of iodine for goiter treatment, that is for thyroid problem you take iodine medicines. And next is for the preparation of organic compounds and definitely iodoform, which is a very important ingredient for organic tests. In the next class we shall be doing hydracids of halogen. Till now, keep studying and all the best. Thank you.